Hey everybody, yeah, this seems to work. Hey, so thanks for popping by to my talk about why you don't need a single page app. It's about why I think you shouldn't at least be considering if you want to use a big framework or not. Few words about myself. My name is Flo. I've been developing web pages for the last 25 years or something, and the last 15 years I spent in e-commerce for reasons that are not quite clear to me yet. But here we are. And yeah, some of the companies I work for, it's, as you can see, it's mostly e-commerce, some of data stuff also, PR, performance advertising. They're a big data ad tech company. And right now I work for eTribe, so I changed sides a little bit. I used to be developer, lead developer, all that stuff, and now I'm a consultant. I help other companies with my company eTribe to bring e-commerce projects to life and to develop new cool software systems. So if you didn't know, this is also a line of work in the software industry, consultancy, where you help other people bring up cool new projects. So it's also kind of interesting because, of course, you get to see more of the world. Okay, so why you don't need a single page app? Let's think about that a little bit. I mean, I handed in this talk, I think, in 2020, before Corona kicked in and everything. And even back then, this was a topic. So there were a few blog posts, and also some of the React core guys said like, ooh, perhaps all this single page app client-side rendering isn't the best thing to do. Let's look at alternatives. And the thing is, 2 years on, there is a traction that some people feel that this is still something that you might consider. But when I speak to our clients at eTribes, it's basically the question, should we use React or Angular? I mean, that's the two frameworks out there. And my point is that perhaps you should use neither and consider what are the alternatives. And this is what I want to talk about today a little bit. To understand where we are and what got us into this thing, let's have a quick recap about the history of web applications. It's going to be 2 slides, not too long, don't worry. Good old days. White page, blue links, kitty pictures, and all that stuff. You probably remember that. You had a server system running here, and it spoke to... Oh, wait, sorry. Yeah, here we go. The pointer work? Never mind, you get it. You have a database sitting up there. It contains some data, and it has a server application, loads the data, stuffs into some templates, outputs HTML pages, and gives it to the user. Plain and simple, super efficient technology. It just worked. So this was the simple ways. Of course, there's a couple of downsides with this approach. I mean, the first one would be you get this white flash of navigation between pages. And also back in the old days when you had your like dial-up modem or whatever, and the page would take a minute to load, this sucked pretty badly. So this is something that you don't want. Of course, you cannot have complex UX. I don't know, overlays, modals, flyouts, all this fancy stuff designers think about. Wasn't really possible with this kind of technology. And the last thing, the user experience sucked. So the users really didn't like what they were seeing there, but there was nothing else, so nobody complained, I guess. And then, of course, some apps were just not possible, like a chat application, these kind of things you cannot do with this old school technology. Now, fast forward for about 15 years, I think the SPA movement kicked in about 2011, 10, I don't know. And what you do these days is that you abstract the server application into the left-hand side, and you have an API that exposes the data. And then up here, you have your front-end application. It's a JavaScript application that lives in the browser. It handles the navigation inside the app. It speaks to some sort of API, loads data, stuffs the data into a templating engine, and then renders the page. And then the user sees the data. So you have the, I don't know, flow of the data, and then React renders the thing. That's what everybody does these days, I guess. And it's cool. It allows you to do some really fancy things. UX can do whatever you want to do with it. But also there's a couple of downsides to the whole thing. Namely is that you've managed to turn a simple website into a distributed system. And that's something that you actually want to avoid. Why is that the case? Because now your application lives on 10,000 devices out there in the wild, different operating systems, weird Chinese Android handies with mobile navigation browsers that nobody understands. So this now makes everything quite complicated. And also your state is distributed. It's that the server sees some side, and then the mobile device or your clients, they have also their source of truth, which they think is their world. The clients get outdated versions. I mean, this makes your whole application much, much more complicated as compared to, I'm going to give you a web page which contains all the data. Also, you need teams that give data through the APIs. If you have a new feature, you need to sync the front-end team with the back-end team because the data must go through the API and the front-end team must receive it. So it doesn't make things too much easier. And also, what's one thing that nobody really thinks about is that there's much more data on the wire than with HTML. So with normal, say, RESTful APIs, they're going to give you this big chunk of data, and in some cases, you might only need like one field out of it. I mean, I understand there's GraphQL and modern technologies that alleviate this problem a little bit, but generally we see that there's a lot of data transfer that is just not used by the clients. So yeah, that's some of the downsides. And then it gets worse. You have server-side rendering, of course, too, because then there's these weird bots out there on the internet. Nobody knows what they do and how they work. Generally, people feel that Google might be able to index single-page pages, but perhaps not. So it's quite of uncertainty there. So what you do then is you take your React application, you have it run here in a headless browser on your server, then hydrate the state of the server, give it to the front end takes the state, dehydrates it, starts rendering the page again, and then you have a web page running on the user. I mean, that is kind of complicated, isn't it? I mean, this is something where you say, well, why not just give them HTML pages and be happy with what you got? And in the past few years, as I said, there was this movement to making things more simple in the front end. And I'm not alone with this opinion. I don't know, some blog posts and some stuff I pulled around. So especially noteworthy, I guess, is Dan Abramov, core developer of React, who at this post says, well, perhaps this whole rendering on the client wasn't the best of ideas. Perhaps we should consider going back and doing stuff on the server, because it's a much more controlled environment and it gives you also quite a number of advantages. And some other blog posts, feel free to have a look at them. But generally, my takeaway with the last, 10 years of React and Angular development really is that it's quite easy to get these applications wrong. So state management, routing, data, I mean, of course, probably not much is being said about that. This is complicated. It makes a page really hard to own. Also this, I'm going to run my app on the edge. It's going to run on Kubernetes. It's going to run this and this there. And also the server-side rendering are hard to tackle. And especially what I also feel is that the tooling has become really complex. I mean, Webpack, Rollup, give this to a junior developer, he will not figure out what's going on. So the tooling in the JavaScript world is super diverse, new frameworks coming out every other week. And to really understand what's going on there, it is hard. It's really, really hard to figure out what's going on. And this overwhelms juniors. And this also makes your code much quicker obsolete. I mean, if you think about that, there's, apps out there, server-side rendered apps that have been running for 20 years unchanged. And with front-end apps, React, Angular, I feel that basically every 3 years you need to implement everything over from scratch because there's so much movement in the whole scene. And I feel that a lot of these issues here, you're much better off on the server. One quick interlude slide here, it's not too much front-end related, but what you also have to understand is that these days when you're developing, say, a new front-end, a new shop system, you would not develop much of the back-end applications yourself. So you might be going to, headless CMS, Storyblock, gives you your content data. And then you have an e-commerce system, search, wishlist, whatever. You have identity providers. So point being is that in a lot of cases, you would just buy these systems because it's actually not worth really developing them yourself, because there's solutions out there that can cover your use cases and you just buy into them. Then you focus on the front end, with which you expose through a GraphQL API. And this leads to believe that actually it's a good idea to structure your applications a bit different. And what I'm proposing is something like this. It looks similar, but it's not exactly the same. So what you have here on the left-hand side is you got a couple of APIs. You speak to these APIs, they give you data, not HTML. And then you have a front-end application, which speaks to these APIs and renders HTML. So please note the difference with this thing now is it's not that you have this big monolithic front end which does everything and renders the HTML from the data it just received from a database. It's a separate entity and it's a, basically, if you will, front end application, but it lives in the back end. It's there to serve data, serve HTML to the front end. So that's basically the biggest difference to the thing that we had before. If you stay along this line of thought, then of course you got to think about what can be done to make this side of server-side rendering, so pretend I'm a browser, but actually I'm running on the server, to make this as nice as possible. And now going back in history, down the memory lane, this dude over there, Thomas and I worked together for the last 10 years or so, and I think at that time we were working for Swarovski, that must have been 2019, building a really complex web shop system, commerce tools, CMS, GraphQL, the whole shebang we were doing there. And at some point we sat together and said, like, oh, this is all really bloody complicated what we're doing here. I mean, we're just building a shop. It's not that we're building, an operating system. And then Thomas sat down for a couple of weeks and said, okay, I'm going to do exactly the opposite of what we're doing now. It's going to be the most slimmed down, most rudimentary, simple server-side rendering front-end framework, but also that can play a role in the front-end. We'll get to that bit in a bit. So if you want to have a look at the thing, it's called Nanoweb. Keep in mind, if a developer normally comes to me and says, can we please use my own framework or library? I would most certainly say, no, absolutely not. But given the thing that this comes from Thomas, we really appreciate in terms of coding, but also that the thing is basically 300 lines of code. So it's not a framework, it's a library. It's basically putting together some really clever tricks to get front-end rendering done. I can only recommend check it out, but we also talk about alternatives later on this thing because a lot of them work the same. We did assess the market, of course. Let's not build something if there's cool stuff out there. And it turns out there isn't actually so much stuff that allows server-side rendering. I mean, of course, you got the classics, I don't know, Laravel and Phoenix and all these server-side frameworks, but they are quite opinionated and they're tied to a specific programming language. Why I put the Livewire in here also is that these frameworks also have some sort of new front-end technology tacked onto them, but generally they are server-side frameworks. React also has a thing for server-side rendering. It's called React Server-Side Components. It's been around for 3 years now or so, I think, but it's still marked as experimental and probably something you don't want to use in production. So, but React also has this thing. And then there's a couple of other solutions which are backend agnostic. So basically they are JavaScript based and they allow you to speak to APIs and generate HTML out of it. Lit is among one of them. Then this Nanoweb thing. And another one I just found this morning is called enhanced.dev. It shares some similarities also with the ideas in Nanoweb, but they all work quite similar. In this talk, we're going to focus a little bit more on the Nanoweb because it has both sides. It has the server-side rendering part, and it has also the fancy SPA-ify, my front-end application to it. But let's first look at the server. Because not everything is bad in React and Angular, of course. These are fantastic frameworks, and there's, I don't know, probably the brightest engineers put their brains into it. So you can't say that this is all bad. So what we wanted to do is we wanted to achieve as much compatibility with what people are used to in the React world, but bring it to the server. So first of all, need to think about what kind of server you want to use. We opted for Node.js because that server that we're going to have, it needs to speak to a lot of APIs. That should be not blocking. So I don't know, PHP or Python are doable, but probably not such a good fit. And then you could use Go, but then you have to do a lot of the groundwork yourself. I mean, Node.js is silly fast, scales really well, and it is a quite decent solution. Then the next thing. What I really liked about React a lot is the functional components. I think this is probably the best idea they ever had. So for those of you who have used it yet, so what it means essentially, you have a function. That function receives parameters, props they call it. And then these parameters are put into the output of your function, and the output of your function is HTML. So it's basically a function to receive data and convert that data into HTML. And what you can do with these functions, you can nest them. So you can have a function, and in that function you have another function, so you nest them down, and at rendering time, React runs down to the very bottom and starts outputting, and then goes up the tree again and spits out the HTML. That's what we wanted to copy on the server, but of course you don't want React on the server because React is state handling, click management, event bubbling, all these things. On the server you don't need that, right? You just want output HTML. And it turns out there's a feature in JavaScript called tag template literals. I had never heard of them before. It's a bit of a weird thing, but they work actually quite well. I'll show in detail a little bit how they work. And then as a last thing, that's also a concept from React, which I think is cool. It's called contexts. It's with these functions, for example, if you have a user, which is something that you're probably going to need a lot of times in your components, and you don't want to pass in the user at the top and hand it down all the way through the chain. This is where the contexts come in. A context allows for a component to reach out, speak to the context, and get some data from it. And it turns out also Node.js has this thing. It's also a bit of a weird feature. Nobody really knew what to do with it. But this is called async local storage, and it is exactly what a context does. You reach out and it gives you back data that is stored between different components. About the tag template literals, sorry. You probably know the template literals. It's this backticks thingy here. So the one after the template here. So is this? No, it's not working. Okay. Yeah, so that's a normal template literal without the template before. And it turns out that in JavaScript, there's a feature called these tag templates. And what that means is you create a function and you prefix the template, like the tags, with the function. So in our case, template is the function that we're calling. And what it does, it receives the strings and the arguments as an array. And we are just outputting console log here. So if you look at the thing, for example, in our case, we're putting, hey, then $ curly braces, how are you? And who is code.talks in this case? And what the output of that function would be is, and then the black box here, so you get the two static strings, which is how and comma, how are you? And then the other thing is the array. These are the arguments that are passed. This is code.talks. In this case, is a string. And if you think about this a little bit, then in this function, I can do, of course, much more than just console log. I can have a look at the argument and see, oh, is this actually another template? And then I need to render it. Or is this actually an array? Then I need to iterate over the array and see what's in it. So in here, I'm doing essentially what also React is doing, when it looks at the JSX elements and sees what to do with it to render it. Cool thing, for example, you could also return a promise in one of these options and one of these arguments in here. And what you would need to do in this case, you would wait for the promise to resolve, and then you start rendering it. So you actually have quite a lot of possibilities to do React to these kind of weird template literals. Just to give you an idea how this would look like in real life, this is something which would be basically the root template in an application. So you see, you have a function, it's called base, it receives props, which is of an object, which title is a string, and then it receives children. I mean, if you know React, this is basically how it looks like in React. And then we have this template literal, which is the thing on the right-hand side, this HTML we called it, and then the backticks. And then this is just HTML. Goes there, and then you replace the variables, and then you put the children in here. And this is your core function. And if you continue a little bit, this would be a page option, for example, now. It takes the base function that you just saw, and it injects further elements. So the HTML backticks you see here, this is another template literal, and this is what you're passing as children to the function that you just saw. And if you look at this, I mean, it's not JSX, it's not React, but it is fairly similar, I would say. So you have to get used to the thing that you can't just write HTML, but you got to prefix the stuff you want to inject with these template literals. But other than that, it feels fairly similar. This is like a functional component that gives me HTML when I run it. And it's also quite fast. So that's the cool thing about it. We did some tests with it. So for an average size, you can expect a page rendering time between 5 to 10 milliseconds, depending on how much stuff you have on that thing. And this is quite fast. I mean, if you think about, I don't know, PHP, fast frameworks, probably 30 milliseconds or so is the fastest you can get. So this allows you to output HTML really, really fast, and still the development feels a lot like you're developing a React application. And also, by the way, you got the IDE tooling, formatting, linting, indenting, so all of that's there, so you don't need to do that yourself. So it's actually quite convenient to work with. Now, as we got this now, so we have an option now to render pages on the server, and it's silly fast. But then at some point, there will be a complaint, of course, that the user experience will be bad, because for now we're just outputting static HTML. And of course, okay, this is not something that we can fly with. Got to come up with some solutions. And now there's a couple of frameworks out there that are quite popular these days. For example, let's have a look at Hotwire. I've probably heard of that one. It lives in the browser, so it's a JavaScript framework, and allows you to dynamically update parts of the page. So basically, you do a call to the server gives you back fragments of HTML, and you put these fragments all over the page and replace what's there. Works really cool. It's an excellent framework. HTMX works similar. I think that they share a lot of similarities here. But what you can also do, and this is what we're going to be doing in this example, you have web components. Web components are a native implementation in the browser. We talk about them in a second. And they allow you to do a lot of the stuff that you were doing with the React state in the past. So it's actually quite powerful. And what's also cool about them is that the browser support is really excellent these days. They used to be super wonky, but for now, it's not a problem at all. So let's go down. How to fix the white flashes. So to fix the white content flashes, we gotta make the browser not re-render the page. The way we did that here was that we have a library running in the browser. It intercepts clicks, intercepts calls. And what this does then is that instead of sending the request to the server, it does an AJAX call, XHR, whatever you want to call it these days. receives the payload, and then in the payload you will have a full page. It's full HTML, no data, completely rendered page with everything. And then what the thing does, it does a delta update. So it checks what's on the page and checks what it received in the call, and then it just diffs the 2 pages. It also checks the headers. Is there a new script in there now? Then it's going to run that script. So it basically does a full update of the page, but without reloading it, but doing this under the hood. This works surprisingly well. This technology has been around for over 10 years now. I think Ruby on Rails had it with something called TurboLinks in the past. And also Hotwire, by the way, is based on TurboLinks. So it's by the same company that does Ruby on Rails. They developed this. Also, the diffing of the DOM works surprisingly fast. So it's 10 to 30 milliseconds. So it's also really snappy. It works quite well. And the only downside you see is that sometimes you would need to resort to web components. For example, if you have a drawer or a flyout open and the user clicks on something and then if you were to replace the complete DOM under the hood, then this flyout would close, of course. And this is where the web components come into play. The web components in our use case allow you to keep state of an application while the application is reloaded under the hood. So with this technology, a library is called MorphDOM. It's also included in the Nanoweb library, but again, the other libraries I mentioned, that they work in a very similar manner. It's just the matter of how granular they allow these updates. Okay, and then the next thing, the state handling. So, okay, this is the other solution I was just mentioning. This is the Hotwire, for example. In our case, what we're going to be doing, and I'll also show an example later on, we're going to replace the full page. Hotwire, for example, has this concept of replacing parts of the page, which gives you some advantages. So you might not have to use web components for some state management. The downside I see with this approach, with having, patched updates where parts of the page are replaced, is that it gets more tricky on the server side. Because now on the server side, you have all these small controllers which give you only small HTML fragments, and they can only live within the context of where they're rendered. So it sort of creates a bit of clutter on the server side, but it depends greatly, of course, on what kind of application you want to be building. So the web component, that's the fun part. It's really surprising what you can do with these days. How they work essentially is that you create a custom HTML element, flow minus component, something like that. And you define this component in JavaScript, and you have code that you can attach to this component that is run when you render it on the page. So on your HTML, you would just say less than flow component and then close less than. So you have that. And there, the thing is that these components allow a shadow DOM. So that means when you render them, they basically get a new document from scratch. So in there, you're a completely blank page. You can do whatever you want. And this also allows you to put JavaScript in it, create new components as you render them. So this is actually quite powerful. But what sucks about it is that when you're in your web component, you don't have access to the CSS from the parent. It's a blank page. So you would need to import all the CSS again, and then you load the CSS multiple times per component. That sucks. You don't want to do that. And what these web components have, and it's also a bit of a weird feature, but it's powerful, is called slots. So I can put HTML elements and also other web components inside of my web component. And when the component renders, the component puts these slots into the shadow DOM. And how this works then is that, for example, I have this drawer open, I reload the page, and what the page does, it injects new slots, and the component updates itself. So the slots get the styling from the parent, and I can also replace them on the fly without having to touch the web component itself. I'll show an example in a sec, then it might become more clear. It's a bit weird concept. But essentially what you use these web components for is that you do state management. Is the component open? Oh yeah. Or is it not open? It's as simple as that. So the components themselves don't have much logic. They only render, an overlay to gray out the background, and then a drawer where you want to put the slots in. Other than that, there's not much logic in them. And so they're actually really easy to use. So looking at how all of this works together, what we have now is that we are rendering everything on the server. It's JavaScript code, output HTML, have the stuff living in the browser, and then we SPA-ify it. So we try to simulate the stuff that happens in a single page app and mimic them with the technologies I just showed. Now, of course, what I'm aware of is that this doesn't work for every kind of application. I mean, if you were to build Photoshop in the browser, it doesn't work. Also, Miro, collaborative stuff, probably is not the best of technologies. But let's face it, a lot of the pages we have are fairly static. So they have a lot of things that don't change too much. It basically says my name on the top or some animations, but in a lot of cases you can get away with not having this. And if you think about it now, this all seems too simple. I guess the best way to showcase what can be done with this kind of thing is a demo. So I hope this works. It's going to be a live demo. And okay, I'm going to change my screen settings here. Give me a second. So let's mirror this. Okay, these are my notes. Let's try this. Okay. You can see, so I can see this too. Okay, so this is a demo shop that Thomas built while we were working for Swarovski. In our case, this thing goes against the Scale API, so it speaks to an e-commerce API that About You has. And the thing is, it's actually quite lightweight. So you can see here from the lines of code, it's a complete shop implementation in about 2,200 lines of code, a little bit of styling. Most of the code is HTML, basically. And we have the thing running here. I'm just going to open it up. And so let's check this out. So you can see here, let's close this for a bit. So you're going to believe me, this looks like a fairly normal shop these days. Yeah, okay, API is working, that's excellent. And as I click around, you see it feels somewhat snappy. It's the staging APIs from About You, so the APIs are not the most performant ones. And also the CDN is not really super fast, so this is why the image loading is not so good. But let's check out some of the stuff that I presented or that I talked about. Let's take this page, for example. I'm going to do a page reload here. And you see, in this case, we cache the response from About You. So getting this data is cached, so just to show this. And as you can see here, I don't know, is this large enough? I guess it is, yeah. So, yeah, I have no idea why it varies a little bit at points, but we get really, really fast page rendering time. So this is, I'd say, fast enough. Let's have a look at the upsides you get, for example, in terms of the bundle size. So in this application, let's take a more complex page, so you believe me this. So let's take this. So this is now a category page. So as you can see, we have on the wire, just going to disable the cache and reload the page so we can see this. We transfer a whopping amount of 53 kilobytes uncompressed JavaScript, which is about factor 25 less than the same page in the real world would be. So because this page is built with Angular in the real world, and this is now the different example. So 50 kilobytes is pretty good, I say. So you see the biggest part of the bundle is the library that does the DOM diffing. Then all the web components get a little bit of JavaScript themselves, and the biggest web component we have is a slider component, which sits at 14 kilobytes. So this is sufficiently fast, I would say. And this is, of course, really light on the browser. Mobile devices love this. They don't need to paste the JavaScript. And then the web components. This is the fun part now. If you check out, for example, this filter here. This thing you see here is the web component. The web component itself is just the gray area on the screen, the overlay, and it's basically the white part in here. Everything else that sits in this web component is put into those slots. So the server rendered this list of sizes and whatever you have in here. And what this allows me to do now is that I can click around here, and you see, and it's a single page app, right? It feels exactly like one. I can click around, the page reloads in the back. I can click around here. I can apply this slider filter that I talked about. So yeah, in this case, you have the full power to bring a page to the user that feels like a single page ad, but with a lot reduced complexity. So I mean, for this whole thing, I think there's 8 dependencies in the whole project. 6 of them are Fastify, and one is like a JSON web token parser, and another one I can't just remember right now. So I mean, this is super lightweight also on the server. And as you saw, this is like a couple of 2,000 lines of code to get all of this. And what this allows you to do, I mean, we can have a look at the DOM, how this looks like, because I find this pretty cool. So if you check out this now, as you see here, this is the web component here, the filter drawer. And this is the shadow DOM. Just gonna unfold this because this is rendered in the browser. And these things I'm passing in here, these are the slots. So I'm just stuffing items into the component. And then inside the shadow root, you can see that essentially this is rendered by the shadow, this is rendered by the web component, this is the overlay. And then in this thing here, you have these slots. And what this does is it just injects the stuff from the outside world into your component. Plain and simple. And when the server re-renders and the filters change, what happens is that the slots change and then the component updates, so it's re-updated. Makes it plain and simple. There's also tons of other ways to get around this, but for now this worked fairly well and allows you to build web pages in a manner that I would say are compelling. I mean, this isn't completely styled through yet, so of course there's a lot of work in the UX department to be done, but I find for a proof of concept this is actually quite powerful and speaking for itself. And what my point on this thing here would be that if you are considering building an application that is not super heavy on the front end, then I guess you should think about a couple of things. That would be, oops, sorry, this one here. Then at least consider the options out there. Just don't go for, let's use React or Angular, because everybody does that these days, but think about what you want to solve and think about the features you will need on your page, and keep an open eye for other technologies that might fit your needs. Because, as I said, having all of this running on the server solves a lot of problems for your application, and it's going to make everybody's life much easier in the future, I guess, because then this is much easier to maintain than having, I don't know, 50,000 JavaScript applications running somewhere in the browser. So, yeah, that was it. Thank you very much for your time. Feel free to pose any questions. I'm happy to discuss this. And other than that, you're going to find the link about the Nanoweb thing on here. And I think also if you want to speak to Thomas, who built the thing, he's in the audience here somewhere, I guess.